All right, for this example, we're going to do the distance of what is the distance of 1 light year in kilometers. All right, so let me start out with this equation right here, which here let me use the mouse. So this equation right here says that the velocity is equal to the distance divided by time. I mean, you've probably seen that equation somewhere in your life. So I mean, the whatever the units of the distance are, like for example, in your car, it's usually miles per hour. In astronomy and in physics, we usually use meters per second or kilometers per second, which is the unit that we're going to use here. So velocity is distance in kilometers divided by time in seconds. And the thing that's important about this equation is that it's true only when the acceleration is equal to zero. And we're not going to really deal with situations where there's a non-zero acceleration, so that's perfectly fine. Now, the speed of light is so important in astronomy and physics in general, that it gets its own symbol, right? And so the symbol is c, right? And so the speed of light, so I'm going to write it in two different ways, or two different units anyway. So it's 3. That's supposed to be a 3. Sorry, 3 times 10 to the 8th meters per second. Or the way that we're going to use it in this particular example, it's 3 times 10 to the 5th kilometers per second. Kilometers per second. And of course, that's true because 1,000. This is obviously true that 1 kilometer is the equivalent of 1,000. Those are zeros. Sorry, 1,000 meters. Right, and so you could easily convert this number to this number. Right, that's how this works. All right. So in this particular example, remember we're trying to find what the distance is in terms if the distance of 1 light year in kilometers. All right, so what is the distance of 1 light year, and we wanna find, and that, by the way, that is a distance that's used all the time in astronomy, and so that's that distance we want to convert to kilometers. All right. And of course, you could just Google that number and just type 1 light year equals and put kilometers and it'll give you the number. But I'd like to derive it right here. And so what's nice about this is it'll show us how to do some calculations. All right. So the first thing is we got to set up the equation. And so I'm gonna go back to this equation right here and rearrange it and solve for the distance. Okay. And so the distance is equal to just bring the t over to this side of the equation, and so it's equal to the velocity times the time. And so it's not just any velocity, we're talking about the speed of light. So it's c times t. All right, so that's the equation that we're going to use. And there, this distance would be what we're going to call a light year, 1 light year, which is of course the distance that light travels in a year. Right, that's the idea. All right, so let's get a new thing. All right, so we have this equation. All right, so distance. Oops, make sure that's working. Distance is equal to the speed of light. So I'm gonna put the number in here. So we're gonna use 3 times 10 to the 5th kilometers per second times a time. And so the time here is going to be 1 year, right? So that's the amount of time. So that's what t equals. T is 1 year, the distance that light travels in 1 year. right? But the thing is, we need the seconds to cancel, right? Here, let me use the mouse. This seconds has to cancel, and so what we have to do is convert 1 year into seconds. All right. So the nice part about this is we'll be able to do some conversions. All right. And so here we go. All right. So I'm converting 1 year into seconds. All right. So in 1 year, I mean, you could have any number here, like 5 years or something like that. But we're just doing 1 year because we're talking about a light year. 1 year, all right, is the equivalent of 365.25. Well, we'll go with this 0.25 days. That's not exactly true, but that's close enough. All right. So notice the years cancel. And so, you already know that, of course, 1 year is 365 and 1/4 day. All right. So then what you do is you say, all right, you use what's called a conversion, right? So we have a conversion between days and hours. I know that 1 day is 24 hours, right? And so really, with this is a conversion factor. What I'm going to do is I've got to cancel the days. Okay, so I've got to cancel this right here. So I put 1 day in the denominator and then 24 hours in the numerator, right? So that's the reasoning. Okay, it's not just haphazard. So 1 day is, of course, 24 hours, and of course the days cancel. All right, so you multiply 365.25 times 24, and you get the number of the number of hours in a year. But we want to go even further than that, and of course this conversion. In 1 hour, there are 60 minutes. Use MIN for minutes. The reason for that is, of course, we reserve lowercase m for meters, so MIN for minutes. And then, of course, in 1 minute, there are 60 seconds. All right, so there we go. So the minutes cancel, the hours cancel. So really, what this time of 1 year, we're trying to figure this out in seconds. So some number of seconds. All right, and so what we do is we multiply 365.25 times 24 times 60 times 60, and let's see. Do I have my calculator? Here it is. Oops, no, not that. That was the wrong one. I thought I had my calculator. There it is. Okay, so scientific calculator on the computer. So here we go. So 365.25 times 24 times 60, which is another way of saying times 60 squared. It just simplifies it. So you multiply all that, and that's the number of seconds in a year. Okay, so the time. All right, so here, let me get a little bit of room here. Let's do this. All right, so here, put this. So the distance is going to equal 3 times 10 to the 5th kilometers per second times the number of seconds in a year, which of course where's my calculator? There it is. So I'm going to put this number right here. So it's going to be 31 million. It makes it go away when I use my stylus. 557,000. 57. Oh, shoot. Here, let me pause it. All right, so I've put this, I had to pause it for a second. Anyhow, so I put this number right here. So it's 31,557,600 seconds in 1 year. And of course, the seconds cancel. Let's do that. That cancels. And so that'll give us a distance. When we multiply 3 times 10 to the 5th times the number, 31 million something seconds, we're going to get an answer in kilometers, right? Because that's the only unit that's left All right, so here, let me flash this calculator again. It keeps going away. Okay, so see, it's already here in my calculator, and so I'm just going to multiply that times 3 times 10 to the fifth. So times, so it's 3, and then okay, so for this calculator, let's see. For this calculator, like different calculators are different. This one uses this EXP button. It's more like a Casio. For example, for Texas Instrument, you usually have to hit a shift and then there's an EE button. All right. So anyhow, this is 3 times 10 to the fifth. So you hit EXP to the positive fifth. All right. So that's 3 times 10 to the fifth. That's how that's that. And so you hit enter, and that will give us. All right. And by the way, so we're going to round it to 2 places past the decimal. All right, so just to let you know, that's what we're about to do. All right. Okay. So there's the full number. Actually, this is good because this will give us a little experience with scientific notation. So you have there's 3 zeros, there's 6 zeros. So I'm moving the decimal place is implied here at the end, so that's 6, 9. And then there's 12, right? So this is going to be 9. Okay, so it's going to be 9.4 something. We'll talk about that in just a second. Times 10 to the 12th, right? So we already know that the answer is going to be 9.4. All right, and remember I said we're going to go 2 places past the decimal, but anyhow, it's times 10 to the 12th. And that's kilometers, all right? So what is that third digit? And by the way, I'll say that in just a second. All right, so let's take a look at it. So if you look at the calculator here, all right, so then it's 9.4, and then if we round it to 1 place past the decimal, I'm sorry, two places past the decimal, like I said before, then you look and you say, all right, you got 6, 7, and so the 7 is the where you're gonna you're ending it after the 6. But what you do is you look one place beyond where you're. I'm not saying this very well. So if it's 2 places past the decimal, you look at the next digit, and if it's 5 or greater, you have to round up. So that 6 is going to turn into a 7. And so let's do that. Come on, 7. Here we go. All right, so that's rounded 2 places past the decimal. All right, and I think I mentioned this before, or if I haven't, I should have. Here's another way of perfectly good way of writing this, and this is the way that you would enter this into Blackboard, by the way. So it would be 9.47, and the Blackboard doesn't. It has its own way of interpreting times 10 to the something. So you use just a capital E, and since this is to the positive 12th, you just write 12. So that is another way of writing 9.47 times 10 to the 12th. And you can answer it either way is perfectly fine. But on Blackboard, you definitely want to use this version, okay? Because that's the way it interprets. That's the way Blackboard interprets that. All right, so there's our example. And so what that distance is, that is 1 light year, right? So that distance of, I'm sorry, I should have put the kilometers right here. So that distance is what, how many kilometers are in 1 light year. So you could even do you have a conversion now. So we know that 1 light year, LY is light year, is 9.4, there's a decimal, 7 times 10 to the 12th kilometers. All right, so that's a conversion in and of itself. All right, you could look that up. And all right, so that's it for this example.